welcome back. As you can see, we're moving on to 8.2. 8.2, we had a packet that I normally print out and give to you at the beginning of a module. Would be you kind of working together. It's kind of a long task. With us home, just doing this online, we're going to be pretty direct, short and sweet. Here's what I'm going to want you to do. What I'll have you turn in on the Canvas page, or if you don't know how to get it on Canvas, email to me. You'll notice at the top here, this says notes and the homework. So you're going to see 3 problems. We're going to pretty much do the first 2 together, a little review. And then number 3 is what you're going to do on your own. And that's pretty much a wrap. It's a review, and then we'll continue on. You want to know 8.1.8.2 pretty well for what we'll be doing in 8.3. So we do want to do this section, even though this is going to be a big review. The first problem here says the equation of the line in your graph is y equals x. So this is the equation y equals x. If you remember our old slope-intercept idea, that our y-intercept for this would have been a 0. And then the number in front of our x is your slope. So we're going to go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. So that's why this line is that equation. They correspond to each other. So I'm going to have you do in this one to start. On the same grid, graph a line that is parallel line that is 3 units above it. So if this is our current one, all I'm going to do is look at my y-intercept, and I'm going to pick that point, and I'm going to move it 3 units up. So 1, 2, 3. I'll do those in red. And if it's a parallel line, and I want you to graph it, what we would know is when we have parallel lines, their slopes are the same. So if we knew that the original line had a slope of 1 here, then our new line, the one that's going to be red, would also have to be a slope of 1. So from this point, we are going to go up 1, right 1, up 1, right 1, up 1, right 1. We could also go down 1, left 1, down 1, left 1. When we have those points, connect them. That's the new line, 3 units above our current line with the same exact slope because they're parallel. I then want you to write the equation of that line, slope-intercept form. So slope-intercept form is the y equals mx plus b. We know that slope must be 1 because it has to have the same slope as the original line. We also just counted up 1, right 1, up 1, right 1. That is our slope. The y-intercept now for the red one. Here's our red, make this big. Our y-intercept is 3. That's where we cross the y-axis. So that's our equation in slope-intercept form. C, write the y-intercept of the new line as an ordered pair. So if I go to that big fat point right here, that's our y-intercept. The y-intercept is 3 as an ordered pair. It's 0, 3. I want you to write the x-intercept of the new line as an ordered pair. So here was the x-coordinate, of the new line as an ordered pair. So here is this point. The x-coordinate would be right here. Sorry, we want the new line. So the x-coordinate, or the x-intercept of our new line is right here. That's where it crosses the x-axis. As an x-intercept, if I ask you to write that as a point, that would be the point -3, 0. So that's our x-intercept written as an ordered pair. Letter E, I want you to write an equation that is for a line that is perpendicular to the given line. So we're going to have to remember now, whenever we're talking about a perpendicular line, so what we were doing right before we left, our slopes are, and then we had these 2 little phrases, 2 lines here for this phrase. They are opposites, reciprocals of each other. Opposite means they have different signs. So if one's positive, the other one's a negative, and vice versa. The reciprocal is when we just flip our numerator and our denominators. If we go back to the original line at the top here, we know our slope is a 1. So if my original slope was a 1, then my perpendicular slope, let's do this and try blue. My perpendicular slope, so that's our perpendicular symbol, has to be the opposite reciprocal. So this would be 1 over 1, so we're going to flip 1 over 1. That's still a 1 over a 1. But since this original slope was a positive 1, the new slope has to be a negative 1. So if I ask you to write the equation for that line, for a line, we're still relying on slope-intercept form. In this case, we know our slope has to be the negative 1 over 1. So we'd have a negative 1x. The y-intercept can really be anything. So you could do plus 0, 1, 2, 3. It really doesn't matter. Any point that's going to land on the y-axis can be our y-intercept. Just for a visual, so we have a little room to work, I'm actually going to add, and I'm going to actually make it negative. So let me get rid of this. I'm going to make it a negative 2. So I'm going to say minus 2 so that we're down here. Then I'm going to count off that slope of negative 1. So from this point, negative 1 as a slope would give me down 1, right 1, down 1, right 1, down 1, right 1. When we connect this, we also said we could go up 1, left 1, up 1, left 1. So now when we connect this line should be perpendicular to the other line. That's what we were doing to F. Should be perpendicular to the original line. Really should be perpendicular to both, really. And then G, what degree angle forms at the intersection of the original line and the perpendicular line? And that would have to be 90 degrees. If we had our protractor, when we were going through our protractor days, put that right here, we would see that we have a nice 90-degree angle. And the reason we would know that without even having to use our protractor is over here, our slopes are opposite reciprocals of each other. 2, pretty much the same. If you look at your original line, we'd have a y-intercept of 0. So that's why we go through the origin. Our slope is here, the negative 2 over 1. So I go down 1, 2, right 1, down 2, right 1, down 2, right 1. So that's our original line. We'll go walk through the basic same steps here. B, write the equation, or letter A, on the same graph, or on the same grid, graph a parallel line that is 3 units above our current line. So I'm going to do that with this original point. So basically take this point, move it up 1, 2, 3. If we are parallel, that means it has to have the same slope. Actually, let me do this one in red so that we know it's different. So we go up 1, 2, 3. That's how we end up here. If they're parallel, that means we should have the same slope. So if the original slope was a negative 2, my new line that's going to be red should have a slope of a negative 2. So I'm going to go down 1, 2, right 1, down 2, right 1, down 2, right 1. We could also go up to left 1. So we connect those, and then we should see those are parallel. They do not intersect. B, write the equation of the new line in slope-intercept form. So slope-intercept form, y equals mx plus ab. You can now either count your slope on your line, or just know it's got to have the same slope as the original one if they're parallel. So we're going to be negative 2x. Our y-intercept now is up here at 3. So that's our new line's equation in slope-intercept form. C, write the y-intercept of the new line as an ordered pair. So here is our y-intercept. So as an ordered pair, that's going to be 0, 3, just like our previous problem. Letter D, write the x-intercept of the new line as an ordered pair. So that is going to be right here. We can see that this crosses, if we were just eyeballing it, it is halfway, and that's what we're going to go with. It actually is halfway. So that would be 1.5, and then comma 0. Letter E, do again this in the bluish color. Write an equation of a line that is perpendicular to the given line. So if we revisit the original line here, the original line's slope was a negative 2. So if my original slope was a negative 2, my perpendicular slope would have to be positive. All right, it's got to be the opposite sign, and it needs to be the reciprocal. So there's your opposite sign. And then the reciprocal of 2 would, right now it's 2 over a 1. We flip those, would be 1 over 2. So the equation of our new line would have to be y equals, and then we definitely have a 1/2 for our slope. Then your x. You could go pick any y-intercept you want. You could pick the 0 here. You could pick this here. They could definitely go through there, just so we have a little room. Yeah, it doesn't matter. Pick whatever you want. I'm going to go down. So I'm going to come down here. And since I put my dot right here, that's on the y-axis at a -3, so that's my y-intercept. I'm then going to count off my slope from this point. The slope of this line is the 1 over 2, so I'm going to go up 1, right 2. Up 1, right 2. 1, right 2. Oh, hold on a minute. Let me change this guy. Too many colors and dots going on here. So, -3 is our y-intercept. Up 1, right 2. This point was good, but then up 1, right 2 should have taken me here. And up 1, right 2 should get me there. Connect those. If we do that correctly, what should have happened is my new line and the line that you were given, when they intersect, the degree of the angle that should be formed there should be a 90-degree angle. And that's pretty much all I am doing with you. Short and sweet today. Again, hopefully all this is a review. We just want to remember this as we move forward. Know that parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other, and be able to write slope-intercept form of equations as well as graph them. All stuff that hopefully we're pretty familiar with. So with that, I'll leave you number 3. Won't take too much of your time today. Go ahead and submit this on Canvas and enjoy your day. Enjoy tomorrow. We will talk to you on Wednesday.